Hello, and thank you for joining us today by watching this video. I'm going to tell you about a total system solution offered by Microchip that will simplify your designs involving motor control or position sensing in a spacecraft or any kind of space environment. You might be asking, how will this solution simplify your design? Well, this solution will dramatically reduce the board space you need for your design, as well as decrease the weight, and consequently, you're going to see a huge increase in the reliability of your application design. So I'm going to talk to you about two companion ICs offered by Microchip. These are relatively new ICs, and one is a mixed signal component. So it is the LX7720 motor control IC with position sensing for space. It integrates commonly used mixed signal functions that are needed in motor control and positioning applications. It's radiation hardened by design, and this one alone can offer up to 75% board space reduction for those same elements that you're replacing, either using discretely or some smaller scale integration. So you get that huge board space savings with the rate reduction and the increased reliability. The companion IC to this is the digital component for these applications, and that is the SAMRH71 MPU. It too is radiation hardened by design. This is an ARM-based MCU running up to 100 megahertz and delivering up to 200 dry stone million instructions per second, or DMIPS. Let's take a look at the demonstration system that we're talking about today. Here we have the LX7720 Rad-hard motor control IC with the SAMRH71 Rad-hard ARM MPU. Each of these components is on their respective evaluation platform or evaluation board. So we have the LX7720 daughter board connected to the SAMRH71 F20-EK evaluation kit. I'd like to note here that while this demonstration, this video, is showing the LX7720 daughter board interfacing with the SAMRH71 eval kit, the LX7720 daughter board can also interface with other digital companion chips. And we have created this daughter board such that it can interface to various platforms that we have for these digital companion chips. For example, the LX7720 daughter board can interface directly with the RTG4 Rad-hard FPGA development kit. So getting back to this system, the demonstration system shown here, you've got the two boards and then also a motor to demonstrate motor control with this, and some simple controls, some accelerating and decelerating buttons, and on-off switch. So let's talk a little bit about each one of these components. First, we have the LX7720 radiation hardened motor control IC. It offers 4 half-bridge drivers with floating current sense for motor coil driving, and it has a resolver to digital or LVDT interface with primary coil driver. There's also 6 bi-level inputs for sensing Hall effect sensors or rotary encoders. The LX7720 is available in QML flows, both Q and V flows, in a 132-pin ceramic quad flat pack. That's a hermetic package. It's 24 millimeters by 24 millimeters. It's also available in a 208-pin plastic quad flat pack in a reduced screening flow option. The radiation hardness of this device is 100 K-rad total dose, 50 K-rad elders, and single event latch up free to 87 MeV. More information can be found on the product webpage on our website with radiation reports available. Our new SAMRH71 Rad-hard MPU utilizes our proprietary radiation tolerant process, the ATMX 150 RHA process. It offers 100 megahertz performance and greater than 200 DMIPS. It's designed to operate over a temperature range of minus 55 degrees C to 125 degrees C. And there is latch-up immunity on this device up to 62 MeV. Total dose performance is 100 K-rad or greater. Single event upset LET is greater than 20 MeV without any system mitigation needed. We've done total dose and single event upset characterization for all of the functional blocks of this device. Regarding data integrity and fault management on the SAMRH71, we have ECC on all the areas of SRAM for this device, and that includes the TCM, the tightly coupled memory, as well as on external memories. There's an embedded integrity checker monitor, and we've done hardening of all the critical design areas on the system on a chip. There's 16 regions of memory protection unit, and this device offers 128 KB of flash with 1 megabyte of SRAM. It's packaged in a 256-pin quad flat pack, and for this device we have added the SpaceWire and 1553 interfaces. Let's look at the demonstration system again. So for the demonstration system, we have the two ICs, the SAMRH71 and the LX7720. The LX7720 is connected with external drivers to the motor. Different types of motors are supported with this IC. You can use a permanent magnet synchronous motor or a brushless DC motor. You can also use a brushed DC motor, as well as stepper motors and AC induction motors. So you see that there's a lot of communication going back and forth between these two devices, and this is how motor control is done using this type of MPU. Taking a look at what each IC does and how it communicates, you see the LX7720 drives the external MOSFETs and senses output currents. You also have the LX7720 current sense delta sigma modulator outputs that are going into the SAMRH71 timers and counters. The LX7720 fault outputs drive the SAMRH71 GPIOs. And then you have the motor encoder that's driving the LX7720 BLI inputs, and then the corresponding LX7720 BLO outputs drive into the SAMRH71 GPIOs. The SAMRH71 senses rotor position using an encoder interface, and the LX7720 gate drivers inputs are driven by the SAMRH71 PWM. And then you have the SAMRH71 driving the delta sigma modulator and charge pump clocks of the LX7720. And that's basically the key elements that are being communicated back and forth in this system. Now that you know a little bit about the different information that's going back and forth between the two devices in this demo, let's look at the demo setup again. You have the two boards with the connector board and cables routing the two boards together. So the demo, to give a little more explanation into what's going on, it runs a classic field-oriented control scheme, that's FOC for short, using two direct quadrature space vectors and one external speed regulation loop. So you have this current sense processing and this FOC algorithm operating within certain parameters. You have that bringing the SAMRH71 CPU at or below 55% loading. And here you go. You can see the demo, almost like being there. You can see the demo live here, and we've turned on the demo system. The two boards start communicating. And you can see that motor start to spin. It's controllable through, the deceleration and acceleration buttons, so you can speed it up pretty fast. And showing you this closed loop motor control system that also uses these radiation hardened by design components, so it's good to go for space. So there you have it. We have shown you a total system solution using two new Microchip ICs built for space applications. There's the LX7720 motor control IC, which gives you a solution for the mixed signal elements. And there's the SAMRH71 MPU that gives you the digital functionality you need. And both, remember, are rad-hard by design. And as such, they give you radiation tolerances needed against the effects seen through total dose, single events, and elders radiation exposures. The LX7720 can offer up to a 75% reduction in board space, and that means this combined solution can give you dramatic reductions in the real estate needed to implement this function. Also, that results in a significant reduction in weight, and also a very nice increase in reliability. Both of these devices are available, and also these development kits, the daughter board for the LX7720 and the evaluation kit for the SAMRH71 are also available. I encourage you to go to our website and look at the different product pages related to these parts. You're going to find not only the data sheet, but you'll find some useful radiation reports, as well as some conference papers and app notes. So please take a look at those web pages. If you do have any further questions or need to ask about any kind of schedules or pricing, please reach out to your sales contact. You can also feel free to contact me directly with the information given in this video, and we hope that you've learned and enjoyed and can see a useful way to simplify your designs using these two devices for your motor control needs for space applications. Thank you.